I want to try one last example of finding a Maclaurin polynomial, and this one's a little bit different in the sense that we're going to have to be a little bit creative to even come up with a Maclaurin polynomial here. Okay, so the reason for that is, look at what we're trying to do in this problem. I'm supposed to find a 4th degree Maclaurin polynomial to estimate the natural log of 1.1. If you imagine just kind of doing the standard Maclaurin polynomial here, where I would do natural log of x, right, that would be my function, then the first thing I would do is find f of 0. Okay, but hold on, that would be the natural log of 0, which doesn't exist. So I actually cannot do that. So the first function that comes to mind, natural log of x, just isn't going to work. Okay, natural log of 0 does not exist. We can't do that. Okay, but a more convenient value we could do is the natural log of 1. So let's try that instead. To make it so we can actually do that, the function I'm going to work with here is f of x equals the natural log of, not x, but x plus 1. That ensures that when I plug in 0, I'm actually able to do that. That would be the natural log of 1, which is just 0. Alright, so let's work with that. I'm doing 4th degree, so I'm going to need 4 derivatives here. So let's see, the derivative of natural log of u is just u prime over u, so the derivative of x plus 1 is 1. So that's just 1 over x plus 1. Or you could think of this as x plus 1 to the negative 1. The derivative of that would be negative x plus 1 to the negative 2. Okay, and you can imagine where this would go from there. Okay, so that would be, let's see, 2 over x plus 1 cubed. And the third derivative would be negative 6 over x plus 1 to the 4th. Okay, but we're not just interested in the functions. Because it's a Maclaurin polynomial, I want to make sure I go ahead and plug in 0 to each of these guys. So let's see what happens. Natural log of 0 plus 1, so natural log of 1 is 0. 1 over 0 plus 1 is 1. Negative 1 over 0 plus 1 squared is negative 1. If I plug in 0 here, I've got 2. If I plug in 0 here, I've got negative 6. Okay, so I've got my values all the way up through the 4th derivative. So now let's use my formula to come up with that polynomial. So my degree 4 Maclaurin polynomial, I'm going to start with f of 0. Then I'll have f prime of 0 times x, f double prime of 0 over 2 factorial times x squared, f triple prime of 0 over 3 factorial times x cubed, and f quadruple prime of 0 over 4 factorial times x to the 4th. So if I clean that up a little bit, x minus 1/2 x squared plus 1/3 x cubed minus 1/4 x to the 4th. Okay, so there's my degree 4 Maclaurin polynomial. Let's try to use it to approximate natural log of 1.1. Now here's something I want you to be careful about. It is tempting to say, well, I'm supposed to just plug in 1.1 here. But actually, if you look back at my original function f, what value of x should I be plugging in to get 1.1 inside there? It's actually just 0.1. So be really careful about that. That's actually the whole reason I did this exercise. So I'm going to plug in 0.1 there for x. So it's 0.1 minus 1/2 times 0.1 squared plus 1/3 times 0.1 cubed minus 1/4 times 0.1 to the 4th. We can actually do this by hand. So that's 0.1 minus let's see, instead of 0.5, that's 0.05. It's going to be 0.00333 and 0.000025. Okay, if you work all those out and add it together, sorry, that was a minus sign, I should get 0.0953. And once again, if I'm interested to see how good my approximation was, let's try it out. What was the natural log of 1.1? 0.0953. So pretty much spot on, and I only went out to the 4th degree polynomial. So you can imagine with an even bigger degree, it would be accurate to even more decimal places.